I are going to make our own little pH scale here and see if we have this correct, because we probably don't. So, Sophia, I'm going to have you, this is just plain old hand soap. She's going to stir that in a little bit. We're going to put some cleaner in this one.
Window cleaner.
Window cleaner. We'll stir that one in. Ooh, did you see that change the color?
Oh, yeah. This didn't do anything.
Let's take the, not much, huh? Okay.
Do you want me to wipe them?
You can put them in the sink if you want. This is just rubbing alcohol.
We don't have real alcohol.
No. There's that one. Keep them in order though. This is
vinegar.
Vinegar. Whoa, that one's pretty, huh?
Yeah.
Wow, that's really pretty.
That's bright.
Yeah.
How many more spoons do we need?
2 more.
2 more. Okay.
Yep. This is going to be baking soda. Yep, our scale is all over the place. We're just going to make plain old salt water. Some salt here.
Do you want me to stir them?
And then just for fun, Sophie, come on this side and you can do the apple juice and you can do the syrup.
Syrup.
Yeah.
So we gotta pick 2 then?
So here. I'm going to have you stir the syrup. Oops. Stir that apple juice.
Wow, that's a pretty color.
Okay, that's pretty good. Whoa, you're splashing. Careful.
Sorry. And that one?
It's just a little bit of regular old Karo syrup. Go ahead and stir that one.
Okay.
Syrup, salt. Okay, let's get all of our stuff ready. Or where it's at.
It still has a...
That's okay. Look, it turned different colors for us. Here.
A couple of them.
Yeah, so look at our pretty colors that we made.
I like this one.
Yeah, so these are examples of different pH levels that we can find everywhere. Some are more acidic and some are more basic. And even our salt water is a different color. What do you think it is, more acidic or more basic?
Acidic.
You're right, it's more acidic. So which one do you think is more basic? Which one stayed more truer to the purple color or got light blue?
This one.
Yep, and alcohol. Yep. Okay, so our next one we are going to bring those over. Just right here where I can see you right there, yeah. And we're going to put this up so that you guys can see
These 2.
that there's some color behind them. And Sophie is going to put the straw in there and start blowing into this one. See if we can change the color just by blowing into it. Keep blowing. So while she's blowing, we're going to... Ocean. Be careful, not too much.
Sorry.
The ocean is getting going through a process called acidification because of the CO2, which is put into the air by fossil fuels and humans and a whole bunch of other stuff. So what Sophie's doing is blowing her CO2 into this water to see if we can change colors.
And don't drink it.
Don't drink it. It might not taste good. And ocean acidification happens because the CO2 goes into the water and it's about 30% absorbed. The ocean absorbs about 30% of the CO2 in the air. And those molecules split and create a positively charged hydrogen ion, which lowers the pH number and pH balance, which causes the ocean to be more acidic. And it's a problem.
That's weird.
Because, look. Sophie, stop. If you can look, do you see this is more purple? This is more, you see they got pink in there now?
Yeah.
That's from you just blowing in there. You changed the pH of it.
So the ocean will soon change colors.
It can't, well, it might change colors, but it could be a problem because there are plankton that live on the ocean. And do you know what photosynthesis is?
What?
It's where plants, one of the ways plants grow, using the sun's energy. And their byproduct when they do photosynthesis is oxygen for us. So if the plankton can't do their photosynthesis process because the ocean is too acidic, we're going to have less oxygen. That's one of the problems we'll have. Less oxygen in the air is probably not very good for humans or animals, huh? So,
but what about the plants? Would they help that?
Plants can help, but still having an ocean that's getting more acidic is probably